Okay, now what should be velocity? Velocity is displacement upon time, and displacement is 200 meter. Time is 20 seconds, so it will be 10 meter per second. So you are observing in case number 2, distance is different, displacement is different, but what is about speed? It is same. Velocity is again changed. We will discuss why speed is same later on. Now let me come to the third case. First pause the video, note all these things. I think you have done it. Okay, so now we are coming to case number 3. In case number 3 is after time 3t by 4, that is to say 30 seconds. It is case number 3rd. Now, in case number 3rd, the object will be at D. So what should be the distance in such scenario? Distance should be equal to 3/4 of 2 pi r. You also can say it should be 3 by 2 pi into 100. You can say it is 150 pi. 250, 53 is 150 pi. Now, if we talk about displacement, it will be AD. Remember, I am only talking about the magnitude of the displacement. And as in the case number 1, you were finding AB, in the same manner you can find AD as 100 root 2 meter. So you can find distance, you can find displacement. Now what will be speed? Speed is distance upon time. Distance cover is 150 pi. Time is 30 seconds. So what we are having here? 3 5s are, again we are finding 3 pi meter per second. And now we have to find velocity. Velocity is displacement upon time. Displacement is 100 root 2 meter. Time is 30 seconds. So it will be 10 root 2 by 3 meter per second. Velocity is again changed. What I am observing, distance is changing. Displacement is changing. Velocity is changing. But speed is not changing. Such type of motions are called uniform circular motion. When an object travels along a circular path with constant speed, but its velocity is changing because of the changing in direction of the motion. Such type of motion are called uniform circular motion. And now we have to come the next case, the final case. What will happen after time t? Okay, let me see what happens. That is the fourth and the final case of that problem. After time t, the complete revolution. In such scenario, distance cover will be 2 pi r, means 200 pi. If we put r is equal to 100, you will get that. Displacement will be 0. जहां से चले थे वहीं पहुंच गए. Initial and final positions are identical, and that is why we get 0 displacement. Now speed, distance cover by time. Distance cover is 200 pi. time is 40 seconds. So speed is again 5 pi meter per second. But what is velocity for the whole journey? It is displacement over time. Because displacement is 0, so we are not worried what is the value of the time here, because we will get 0 velocity. So during a complete revolution, because the net displacement becomes 0, and that is why the velocity for the whole journey is 0. Though there is certain values of velocity at different point, but for the complete revolution, the velocity is 0. Because displacement is 0. Okay? I hope that example is able to explain you the basic concepts of speed and velocity. And I hope you are able to understand them very clearly. Even then, if you feel any type of problems, you have some queries, you may write them in you may write in Facebook or WhatsApp group. Even if that video is available at YouTube, you can write in comment section. Directly you can contact to me. There's no problem if you feel any problem. I'm just closing my video at that time, and in next video I'll discuss few more problem about this, and then we will discuss about average speed, instantaneous speed, etc. Okay, all the best, bachon.